Now that we've looked at the difference between mechanical and electromagnetic waves, we're going to have a look at the difference between transverse and longitudinal waves.
So now let's look at another way to classify waves. Waves can be classified as transverse or longitudinal. In a transverse wave, the particles which make up the medium move in a direction which is perpendicular to the direction the wave travels.
Okay, let's have a look at a transverse pulse now. What I've got here is a slinky coil. So the slinky coil is the medium, and in a second I'm going to send a transverse pulse along it. Okay, so hopefully you can see that the ribbon, which is tied to the slinky coil, is moving upwards and downwards, showing that the medium moves upwards and downwards as the transverse waves travels along the slinky coil.
So examples of transverse wave include waves on a string or electromagnetic waves. In electromagnetic waves, it's actually the electric and magnetic fields oscillating in a direction perpendicular to the direction the wave is travelling. The other type of wave is a longitudinal wave. In a longitudinal wave, the velocity of the wave is parallel to the direction that the particles that make up the medium vibrate. So examples of longitudinal waves include sound waves and compressions sent along a slinky coil. So let's now have a look at this example of a longitudinal wave.
Okay, let's have a look at a longitudinal pulse now. So I'm going to use the same slinky and I'm going to send a longitudinal pulse along it. Pay careful attention to how the white ribbon moves as this longitudinal pulse travels along. Okay, so hopefully you can see that the white ribbon is moving forwards and backwards in the same direction as the pulse travels along the slinky coil. Now you may have noticed that I've been using the terms wave and pulse somewhat interchangeably. They are similar, they both carry energy but not matter over long distances. So the matter does move a bit, the matter of the medium, but it just moves a short distance from its equilibrium position and back again, while the wave travels forwards through space. So they are almost the same things, but a pulse is a short disturbance, while a wave indicates a periodic motion, so it's a continuing disturbance through the medium.